Good day to everyone. My name is K.S. Matthew, a professor in the Department of Computer Science, Rajagiri School of Engineering and Technology, Kochi. Welcome to the course EST 200 Design and Engineering. Innovation and entrepreneurship has been a focus area for more than a decade in all universities and industry across the globe. We have seen many startup companies coming up with innovative products, disruptive technologies, and businesses. Design and Engineering is a new course introduced by KTU in the BTech program starting from their first batch, with the intention of fostering innovation and entrepreneurship in engineering students. As students do this course, they may come up with innovative ideas and concepts, design and develop those concepts as marketable products, and may become entrepreneurs by the time they complete their BTech program. Let us move on to the introduction of the course Design and Engineering. Objectives of this course is to introduce the undergraduate engineering students the fundamental principles of design and engineering, make them understand the steps involved in the design process, and familiarize them with the basic tools used and approaches in the design. Expected outcomes from this course. After the completion of the course, the students will be able to explain different concepts and principles involved in design engineering, apply design thinking while learning and practicing engineering, develop innovative, reliable, sustainable, and economically viable designs incorporating knowledge in engineering. This is the detailed syllabus of the course. There are 5 modules. First module is about design process. Second module, design thinking approach. Third, design communication. 4, design engineering concepts. And module 5, expediency, economics, and environment in design. Assessment pattern. As usual, there will be internal assessment as well as external examination. Internal assessment is for 50 marks. Attendance carries 10 marks. 2 internal examinations, 25 marks. 2 assignments, 15 marks. And end semester examination will carry 100 marks. There will be 2 parts, part A 30 marks and part B 70 marks. These are the textbook and reference books used in this course. Engineering Design Process by Yusuf Haig and Tamer M. Shahin. Engineering by Design, Volant Gerard. Reference book, Exploring Engineering, An Introduction to Engineering and Design by Philip Cosby and Robert Palmer. Engineering Design, a Project-Based Introduction by Clive L. Dim. Design Thinking, Understanding How Designers Think and Work, Nickel Cross. Engineering Design, a Systematic Approach, Pahal and Feldhusen. Let us move on to Module 1 of Design and Engineering course. Design Process, Part 1. These are the topics we are going to discuss in Module 1. Introduction to Design and Engineering Design, different stages of design process, detailing customer requirements, setting design objectives, identifying constraints, establishing functions, establishing specifications, generating design alternatives, evaluating alternatives and choosing a design. Why do people design and invent new products? You can answer the question in the Slido. People design and invent new products primarily for 2 reasons. One is to solve some problems being faced by human beings, and second reason is to meet a need of a human being. So these are the two main reasons for developing new products or inventing new product: to meet some requirements or needs of human beings, as well as to solve some problems being faced by human beings. Let us look at some products, as this course is about product design and development. This is the first camera invented by George Eastman in 1888. This is the first stapler invented by John McGill in 1879. This all of you are familiar with, the first phone invented by Alexander Graham Bell in 1876. And this is known to be the first laptop introduced by a company called Osborne Computers, and the product name was Osborne 1 in 1981. Now let us look at the current form of these products. This is one of the latest camera. This is our current stapler, and this is one mobile cordless phone. This is a mobile phone, and this is a new laptop. So you can see there is a big change or evolution happened in these products. The first camera and the current camera, the stapler, the telephone, there is a big change, and the laptop, of course, there is a big change. So if you look at these products, you can see the first version of the camera and the latest version of the camera. The basic functionality remains same for taking pictures. The purpose is to take pictures. The basic functionality remains same for the old camera as well as the latest camera. So what is the change? What is the change? If you look at, you can see the change has happened mainly in terms of other non-functional features. For example, the size has become very small compared to the old one. It has become very user-friendly, easy to use. The previous camera, the old camera, was very difficult to use. If you want to load a film, you need to enter into a dark room and load the film. Similarly, after taking the picture, you need to again go back to the dark room and unload the film. And then you have to go through a long process of washing the film to get the picture. But in the present camera, it's very easy to use. Just click, you get the picture instantly, right? Of course, there are some additional secondary features added to the camera as well, in addition to the basic function of taking the picture. The old stapler and the current stapler. Old stapler, it was slightly difficult to use. You need to apply pressure to do the stapling, but in the current stapler, you can just use your one finger or thumb to do the stapling. Telephone, there is a big change. Easy to use. It has become very easy to use. And of course, the laptop. First laptop was having about 9.5 kg weight. You cannot even call it as a laptop. You cannot keep it on the lap. But currently, the laptop has become very thin and sleek. So the change product gets innovated not only by enhancing the functions. Products gets innovated by changing the form or shape or style of the product. So a designer or engineer has to focus on not only functionality, and other engineering aspects also has to be considered by a designer or engineer while designing a product. Then only your product will become innovative. Now let us look at some other products. This is the pencil cutter. The current pencil cutter also looks exactly same. It was invented by Bernard Glass-Simone in 1828. The current pencil cutter also looks almost same, but there are some modifications happened in the pencil cutter, because the original pencil cutter had a problem of the waste will fall on the floor, but there is a slight modification with a catcher, pencil cutter with a catcher. so that the dust or the waste will not come down, fall on the floor. Nail cutter, which is having the same problem as pencil cutter, but there is no solution as such. You cannot see any other nail cutter with the same functionality as a CAD saw. So when I was preparing for this course, I searched to see whether there is a modification of the nail cutter to have a catcher like the pencil cutter, and I could find one design with a small catcher inside, but still it has not become very popular, probably because it was not that successful. The problem was still not solved completely, that it is not very popular or available in the market. The first bulb invented by Thomas Alva Edison in 1879, and this is our one of the latest LED bulbs. So you can see the shape and all remain the same, but there is a change in the technology, but otherwise there is not much change. This is a safety pin, which was invented by Walter Hunt, 1849, and we use the same safety pin even now, after 150 years. Even after more than 150 years, we use the same safety pin. Right? So, what could be the reason for not having any improvement in some products like safety pin or nail cutter, whereas there is a big change in products like camera, telephone, and laptop, which are much complex than these simple products like safety pin and nail cutter, where we could not see much improvement? What could be the reason? You can answer this in the Slido question. So the main reason for not having any change in some of the product like safety pin is the problem called habituation. Human beings get used to something. When they get used to something, they ignore the problems. They think it is safe, it is a safety pin, and we need to use it carefully, right? That's the thinking the human beings have, and they start to live with that problem. Even if there is a problem, safety pin is not a perfect design. Definitely, it is not a perfect design. It is having some problem. Many times we get hurt while using the safety pin. Sometimes it opens by itself and prick our body. So it is not a perfect design, but still we think it is not a problem. We don't think it as a problem. We live with that problem, right? That is called habituation. So let us look at this video by Tony Fadell, the father of whiteboard.
In the great 1980s movie, The Blues Brothers, there's a scene where John Belushi goes to visit Dan Aykroyd in his apartment in Chicago for the very first time. It's a cramped, tiny space, and it's just 3 feet away from the train tracks. As John sits on Dan's bed, a train goes rushing by, rattling everything in the room. John asks, "How often does that train go by?" Dan replies, "So often, you won't even notice it." And then something falls off the wall. We all know what he's talking about. As human beings, we get used to everyday things really fast. As a product designer, it's my job to see those everyday things, to feel them, and try to improve upon them. For example, see this piece of fruit? See this little sticker? That sticker wasn't there when I was a kid. But somewhere as the years passed, someone had the bright idea to put that sticker on the fruit. Why? So it could be easier for us to check out at the grocery counter. Well, that's great. We can get in and out of the store quickly. But now there's a new problem. When we get home and we're hungry and we see this ripe, juicy piece of fruit on the counter, We just want to pick it up and eat it. Except now, we have to look for this little sticker and dig at it with our nails, damaging the flesh. Then rolling up that sticker, you know what I mean, and then trying to flick it off your fingers, right? It's not fun, not at all. But something interesting happened. See, the first time you did it, you probably felt those feelings. You just wanted to eat the piece of fruit, but you felt upset. You just wanted to dive in. By the 10th time, you started to become less upset. And you started to just do the peeling the label off. By the 100th time, at least for me, I became numb to it. I simply picked up the piece of fruit, dug at it with my nails, tried to flick it off, and then wonder, was there another sticker? So why is that? Why do we get used to everyday things? Well, as human beings, we have limited brain power. And so our brains encode the everyday things we do into habits. So we can free up space to learn new things. It's a process called habituation. And it's one of the most basic ways as humans we learn. Now, habituation isn't always bad. Remember learning to drive? I sure do. Your hands clenched at 10 and 2 on the wheel. Looking at every single object out there, the cars, the lights, the pedestrians, is a nerve-wracking experience. So much so that I couldn't even talk to anyone else in the car, and I couldn't even listen to music. But then something interesting happened. As the weeks went by, driving became easier and easier. You habituated it. It started to become fun and second nature. And then you could talk to your friends again and listen to music. So there's a good reason why our brains habituate things. If we didn't, we'd notice every little detail all the time. It would be exhausting, and we'd have no time to learn about new things. But sometimes habituation isn't good. If it stops us from noticing the problems that are around us, well, that's bad. And if it stops us from noticing and fixing those problems, well, then that's really bad. Comedians know all about this. Jerry Seinfeld's entire career was built on noticing those little details, those idiotic things we do every day that we don't even remember. He tells us about the time he visited his friend, and he just wanted to take a comfortable shower. He'd reach out and grab the handle and turn it slightly one way, and it was 100 degrees too hot. And then he'd turn it the other way, and it was 100 degrees too cold. He just wanted a comfortable shower. Now, we've all been there. We just don't remember it. But Jerry did, and that's a comedian's job. But designers, innovators, and entrepreneurs, it's our job to not just notice those things, but to go one step further and try to fix them. See this person? This is Mary Anderson. In 1902 in New York City, she was visiting. It was a cold, wet, snowy day, and she was warm inside a streetcar. As she was going to her destination, she noticed the driver opening the window to clean off the excess snow so he could drive safely. When he opened the window, though, he let all this cold, wet air inside, making all the passengers miserable. Now, probably most of those passengers just thought, it's a fact of life. He's got to open the window to clean it. That's just how it is. But Mary didn't. Mary thought, what if the driver could actually clean the windshield from the inside so that he could stay safe and drive, and the passengers could actually stay warm? So she picked out her sketchbook right then and there and began drawing what would become the world's first windshield wiper. Now, as a product designer, I try to learn from people like Mary, to try to see the world the way it really is, not the way we think it is. Why? Because it's easy to solve a problem that almost everyone sees, but it's hard to solve a problem that almost no one sees. Now, some people think you're born with this ability, or you're not, as if Mary Anderson was hardwired at birth to see the world more clearly. That wasn't the case for me. I had to work at it. During my years at Apple, Steve Jobs challenged us to come into work every day, to see our products through the eyes of the customer, the new customer, the one that has fears and possible frustrations, and hopeful exhilaration that their new technology product could work straight away for them. He called it staying beginners and wanted to make sure that we focused on those tiny little details to make them faster, easier, and seamless for the new customers. So I remember this clearly in the very earliest days of the iPod. See, back in the 90s, being a gadget freak like I am, I would rush out to the store for the very, very latest gadget. I'd take all the time to get to the store, I'd check out, I'd come back home, I'd start to unbox it. And then there was another little sticker. The one that said, charge before use. What? I can't believe it. I just spent all this time buying this product and now I have to charge before use? I have to wait what felt like an eternity to use that coveted new toy? It was crazy. But you know what? Almost every product back then did that. When it had batteries in it, you had to charge it before you used it. Well, Steve noticed that, and he said, we're not going to let that happen to our product. So what did we do? Typically, when you have a product that has a hard drive in it, you run it for about 30 minutes in the factory to make sure that hard drive is going to be working years later for the customer after they pull it out of the box. What did we do instead? We ran that product for over 2 hours. Why? Well, first off, we could make a higher quality product, be easy to test, and make sure it was great for the customer. But most importantly, the battery came fully charged right out of the box, ready to use. So that customer could just, with all that exhilaration, could just start using the product. It was great, and it worked. People liked it. Now today, almost every product that you get that's battery powered comes out of the box fully charged, even if it doesn't have a hard drive. But back then, we noticed that detail, and we fixed it. And now everyone else does that as well. No more charge before use. So why am I telling you this? Well, it's seeing the invisible problem, not just the obvious problem. That's important, not just for product design, but for everything we do. You see, there are invisible problems all around us, ones we can solve. But first, we need to see them, to feel them. So I'm hesitant to give you any tips about neuroscience or psychology. There's far too many experienced people in the TED community who will know much more about that than I ever will. But let me leave you with a few tips that I do, that we all can do, to fight habituation. My first tip is to look broader. You see, when you're tackling a problem, sometimes there are a lot of steps that lead up to that problem, and sometimes a lot of steps after it. If you can take a step back and look broader, maybe you can change some of those boxes before the problem. Maybe you can combine them. Maybe you can remove them altogether to make that better. Take thermostats, for instance. In the 1900s, when they first came out, they were really simple to use. You could turn them up or turn them down. People understood them. But in the 1970s, the energy crisis struck, and customers started thinking about how to save energy. So what happened? Thermostat designers decided to add a new step. Instead of just turning up and down, you now had to program it, so you could tell it the temperature you wanted at a certain time. Now that seemed great. Every thermostat had started adding that feature. But it turned out that no one saved any energy. Now why is that? Well, people couldn't predict the future. They just didn't know how their weeks would change season to season, year to year. So no one was saving energy. And what happened? Thermostat designers went back to the drawing board, and they focused on that programming step. They made better UIs. They made better documentation. But still, years later, people were not saving any energy because they just couldn't predict the future. So what do? We put a machine learning algorithm in instead of the program that would simply watch when you turned it up and down, when you liked a certain temperature when you got up or when you went away. And you know what? It worked. People are saving energy without any programming. So it doesn't matter what you're doing. If you take a step back and look at all the boxes, maybe there's a way to remove one or combine them so you can make that process much simpler. So that's my first tip. Look broader. For my second tip, it's to look closer. One of my greatest teachers was my grandfather. He taught me all about the world. He taught me how things were built and how they were repaired, the tools and techniques necessary to make a successful project. I remember one story he told me about screws and about how you need to have the right screw for the right job. There were many different screws: wood screws, metal screws, anchors, concrete screws. The list went on and on. Our job is to make products that are easy to install for all of our customers themselves without professionals. So what did we do? I remembered that story that my grandfather told me. And so we thought, how many different screws could we put in the box? Was it going to be 2, 3, 4, 5? Because there's so many different wall types. So we thought about it, we optimized it, and we came up with 3 different screws to put in the box. We thought that was going to solve the problem, but it turned out it didn't. So we shipped the product, and people weren't having a great experience. So what did we do? We went back to the drawing board just instantly after we figured out we didn't get it right. And we designed a special screw, a custom screw, much to the chagrin of our investors. They were like, "Why are you spending so much time on a little screw? Get out there and sell more." And we said, "We will sell more if we get this right." And it turned out we did. With that custom little screw, there was just one screw in the box. It was easy to mount and put on the wall. So if we focus on those tiny details, the ones we might, or that we may not see, and we look at them and we say, are those important, or is that the way we've always done it? Maybe there's a way to get rid of those. So my last piece of advice is to think younger. Every day I'm confronted with interesting questions from my 3 young kids. They come up with questions like, why can't cars fly around traffic? Or why don't my shoelaces have Velcro instead? Sometimes those questions are smart. My son came to me the other day and I asked him, "Hey, go run out to the mailbox and check it." He looked at me, puzzled, and said, "Why doesn't the mailbox just check itself and tell us when it has mail?" I was like, that's a pretty good question. So they can ask tons of questions. And sometimes we find out we just don't have the right answers. We say, "Son, that's just the way the world works." So the more we're exposed to something, the more we get used to it. But kids haven't been around long enough to get used to those things. And so when they run into problems, they immediately try to solve them. And sometimes they find a better way. And that way really is better. So my advice, and that we take to heart, is to have young people on your team, or people with young minds. Because if you have those young minds, they cause everyone in the room to think younger. Picasso once said, "Every child is an artist." The problem is when he or she grows up, is how to remain an artist. We all saw the world more clearly when we saw it for the first time, before a lifetime of habits got in the way. Our challenge is to get back to there, to feel that frustration, to see those little details, to look broader, look closer, and to think younger, so we can stay beginners. It's not easy. It requires us pushing back against one of the most basic ways we make sense of the world. But if we do, we can do some pretty amazing things. For me, hopefully that's better product design. For you, that could mean something else, something powerful. Our challenge is to wake up each day and say, how can I experience the world better? And if we do, maybe, just maybe, we can get rid of these dumb little stickers. Thank you very much.
Now let us look at some other products. This was one of the best products before 2000. This was called as pager. It was there till 2001, from 1949 to 2001. This was a very good product used by companies to communicate with their service personnel on the field. There is another product which was there till early 2000. Palm PDA, Personal Data Assistant, primarily introduced by a company called Palm, and there was a Palm OS inside that. Now the company itself is not there. Then Microsoft, Apple also had a PDA, 1993 to 1998 it was there. Then there is a famous iPod by Apple. Microsoft also had a similar product which was called Microsoft Zoom. Do you know which is this mobile phone? This is a mobile phone from a company called BlackBerry. I remember early 2000, I had only a small normal phone, mobile phone. But when sometimes I used to get mails from people, and at the bottom of the mail you will see below the signature you will see a line stating that sent from my BlackBerry, right? So BlackBerry was the first phone with the email feature, right? And having a BlackBerry was considered as a status symbol, and that's why the BlackBerry added that line at the end of the mails. And what happened to BlackBerry? Is that company there now? Is that phone available now? No. With the introduction of iPhone in 2007 by Apple, this phone went out of market, and they did not innovate that phone further to compete in the market, and naturally that product died. HD-DVD. After DVD, one company introduced HD-DVD, which was having higher capacity than the normal DVD. But this product did not survive in the market. It was there only for a few months in the market. After that, what happened is Blu-ray disc came to the market, which was having much higher capacity than HD-DVD, and HD-DVD went out of market. You might remember this phone. This is not the new phone or proper phone. This is a deformed phone. This is the model Samsung mobile phone, smartphone, Galaxy Note 7 2016. This phone was having a lot of features. It was full of features. Samsung filled up this phone with a lot of features, but the designers ignored certain other engineering aspects of the phone, like security of the phone, battery of the phone. All these were not given much importance, and what happened was battery got heated up, and there were many cases of mobile phone exploding, and there were injuries for many people because of phone explosion, and naturally the phone was withdrawn by Samsung. The phone went out of market. This is the famous Titanic ship, which was sunk on its first journey because of some problems in the design. It met with an accident. It hit an iceberg, and that created the problem, but the design was also having some problem. That's why it sunk. This is the Leaning Tower of Pisa. It's again a problem with the design. That's why it slanted. There is a famous Palladio bridge. All of you are aware of it. What happened? So these are the products or designs that failed in the market. So what could be the reason for failure of this product? We have discussed some of the reasons, like competitor products came in the market, which resulted in the failure of the product. Designers do not consider all engineering aspects while designing the product. That was another reason for product failures. So you can give your views in the Slido question. So what is the design? Now we look at various definitions of design and various terminologies that we may come across during this course. So what is a design? Design is a blueprint for creating an object, a product or service. Design is envisioning and giving form and shape to object which could be used to solve problems. Design will help the users to visualize the product or shape or form of the product which is going to solve some problem. These objects can be a structure, a tool or a machine or a circuit, a building, a landscape, physical goods, services, software, graphics and processes. This object we are going to create could be anything of this sort. And the design could be a drawing or a 3D model in the full scale or a reduced scale, produced to show the look and function or working of any object before it is constructed. Design is how we communicate the functions as well as the form of the product to other people. And these objects could belong to different domains or different engineering branches. And the design approaches could be different and specific depending on the domain in which the object falls. Why do people design products? We design things or objects in order to meet a need or to find a solution for a problem. The needs and problems are of different types. It could be personal or individual. It could be organizational problems. It could be societal problems. It could be a problem of a nation. It could be a universal problem. Also, we design objects designed to make the object usable and interesting. The design of an object for the same purpose from two designers or design teams could be entirely different. Even if two designers or two design teams design an object for the same purpose, the designs could be entirely different because no two individuals or no two teams will think. Another term that maybe we will come across when we talk about design: analysis and design. Analysis and design are two processes which go hand in hand. Analysis can be considered as understanding or defining the problem, and design may be described as defining the solution of the problem. Choosing the best solution for multiple alternative solutions is the responsibility of an engineer. When an engineer designs a product, he will not stick to only one solution for the problem. He will try to generate multiple alternate solutions for the problem, and from the alternate solutions, he will choose the best solution for implementing that solution. Objects and products may fail due to failure in either analysis or failure in understanding the problem or in design. Failure in coming up with the best solution for the problem. So what are the major reasons for product failures? Failure to understand the customer needs and problems, competitors coming up with better products. If you don't innovate your product, even if you have a good selling product for your company, if you don't innovate that product, if you don't enhance that product by adding additional features or improving the performance of the product, it is 100% sure that within 6 months your product will go out of the market, because some other companies will come up with some product which is much better than your product, and that product will kill your product and your product will go out of the market. So nowadays the life cycle of a product is very small. It is less than 6 months. So if you don't innovate or change your product for 6 months, be sure that product will die. Not innovating or improving the product continuously, not addressing different engineering aspects while designing the product, wrong selection of materials, process, technology and people, wrong technology or not enhancing the product to take advantages of new technology, wrong time to introduce the product in the market. I said it is also very important to introduce time of release of the product in the market. If you start designing a product and if it takes an year for you to release the product in the market, by the time you are ready with the product, there will be already much better products in the market and you won't be able to release your product and your product will not sell. So timing to introduce the product in the market is also important. It is very essential that we need to introduce the product quickly, very fast. Otherwise, by the time we introduce the product in the market, there will be already much better products than your product. Two aspects for any product design. Function. It addresses the direct and implicit needs of the customer. Form addresses the non-functional features of the product like strength, reliability, usability, sustainability, safety, security, maintenance, aesthetics, ergonomics, and cost. A designer or a design team has to consider both function and form while designing or innovating a product. What is engineering design? As per ABET, Accreditation Board for Engineering and Technology, engineering design is the process of devising a system, component, or process to meet the desired needs. It's a decision-making process, often iterative, in which the basic sciences, mathematics, and engineering sciences are applied to optimally convert resources to meet a stated objective. Engineering design always highlights product function over its form. Engineering design is not styling first, rather styling is second. For example, consider the case of a fashion designer or an interior designer. A fashion designer may design an attractive dress, but it may not cover the whole body, which is the basic purpose of a dress. So fashion designer will give more importance for the form factor or the attractiveness or the user friendliness, look and feel, ergonomics, and they may not give more importance for the function or the need for that product. Again, consider the example of an interior designer. Interior designer may design an interior of an hall very elegantly, attractive designs. He may come up with attractive designs for the interior of a hall. By doing that, he may compromise the utility of the room or space. So, design in other domains may focus on the form, whereas the engineering design always focus more on function over its form. Engineering design includes the following fundamental elements: identifying customer needs and market analysis, establishment of objectives and constraints, establishing functions and forms, generating design alternatives and choosing a design, construction, testing, and evaluation. These are the different elements involved in engineering design. As in any other activity, there are different levels of difficulty in design as well, engineering design as well. These are adaptive design or evolutionary change. Sometimes designers may adapt the existing designs or existing products and do some minor modifications in the dimensions or materials and other technical specifications. So here the product is getting evolved over a period of time with only slight improvement. The examples we can see are elevator, for example, elevator. If you remember, the old elevators were having doors, manually operated grill doors. After some time, that was replaced by automatic doors. Now you can see lift with automatic doors, as well as there will be announcements when the lift reaches each floor. So, but overall look and feel and the functionality, everything is same, more or less same. Only such small changes have happened over a period of time, right? So that is called adaptive design or evolutionary design. Whereas second level of engineering design is new or development design or innovation. Designer may develop a new product from a new idea or concept. He may come up with a new product which is not available in the market, which similar products are not available in the market. That is called new design or innovation. Similarly, designer may also start from an existing design, but the final design, final outcome may differ drastically from the initial product. That is called development design. Example for this could be a manual gearbox car to an automatic one, or a traditional tube-based television to the modern LCD and LED screens, LED TVs, the invention of mobile phone. So all these are examples of new or development. What are the reasons for the failure of engineering designs? Incorrect or overextended assumptions. Whenever we design things, initially we may not have all the information, all about the requirement, for example. We may not be very clear on all the needs and requirements of various stakeholders. And we may take some assumptions. Whenever we take some assumptions, it could be wrong, or if it could be true or false. If the assumptions go wrong, the decisions we have taken based on that assumption will also be wrong, which may result in the failure of your product or failure of your design. Poor understanding of problems to be solved, incorrect design specifications, faulty manufacturing and assembly, error in design calculations, incomplete experimentation and inadequate data collection, errors in drawings, faulty reasoning from good assumptions. In some cases, the assumptions you have taken may be true about a problem. Suppose you assume that this is one of the common problem faced by this user, and he has not stated that clearly, but you assume that this is one problem your customer is facing. The problem assumption may be correct, but then you will try to find the root cause or find a reason for that problem. So sometimes the reason you have identified may not be right, though the assumption is correct. Assumption is correct, but the reason behind that problem or assumption may not be correct. That is what is called faulty reasoning from good assumptions, which is also a challenge in the engineering design. Design objectives. Design objectives are the key aspects or key problems that design will address. Design objective can be defined as a feature or a behavior that we wish the design to have or exhibit. It is also sometimes referred to as design criteria. Irrespective of the domain, the design objectives, the most significant feature to be realized by the object, has to be defined prior to commencing a design. So before you can start the design objectives have to be set. Now let us look at design constraints. Design is not an independent process or open process. It is bounded by numerous restrictions or limitations. These restrictions or limitations imposed either externally or internally to be adhered by the design are called design constraints. There will be restrictions and limitations imposed by the internal factors, internal organization, or by external entities, which has to be adhered by the design. Those are called design constraints. A proposed design is not satisfactory or is useless if these restrictions are violated or disturbed, whereas the objective may be totally or partially realized. Your product may be treated as achieving the objectives of the product, but it doesn't satisfy certain constraints. The product is not really usable, or sometimes you can say the product is useless if some of the constraints are not satisfied, even if it meets the objectives partially or fully. So design constraint could be imposed on the function or form of the product, technology used to develop the product, materials to be used for the product, time to develop the product, cost of the product, etc. Constraints could be in any. The example of design constraints of portable television could be maximum size of portable TV should be 10-inch. Maximum cost of portable TV should be less than 2,000 rupees. Weight of portable TV should be between 1.5 kg and 2 kg. Meet safety regulations. So portable TV should conform to the RF radiation regulations of design functions. We talked about two aspects of design, function and form. So what are design functions? Functions are the fundamental things a designed object or process is expected to do. They indicate the most important attributes that the system or the product is supposed to perform. Understanding functionality is crucial for an effective design. Design functions can be categorized into two: basic functions and secondary functions. The main work that the product or the device or the system is intended to do is called the basic function. For example, making and receiving calls is the basic function of a mobile phone. Showing the time is the basic function of a receiver. In addition to performing the basic function, the product may also provide some other functions too. They are called secondary functions. For example, features like SMS, chat, playing music or video, etc. are the secondary features or secondary functions of a mobile phone. Display of day and date, alarm, stopwatch, etc. are the secondary functions of a design forms. Design form is all the non-functional attributes of a product or object, including but not limited to its shape, structure, strength, look and feel, color, aesthetics, reliability, robustness, etc. A simple example is the car. There are many different shapes and forms of cars from different manufacturers, all serving the same main function of transporting people. A simple example is the car. There are many different shapes or forms of car from different manufacturers, all serving the same main function of transporting the car. But the form is different for different cars. Form is also important for designing a successful product, though engineering design always highlights product function over it. Design means is a way or a method to achieve a function. This can be decided by doing some research or surveys. A preliminary design is then made, which can be further optimized by collecting user feedback. Design means is a way or a method to achieve a function. It is how you are going to implement a function. That may vary from one designer to other designer. There will be alternative ways of implementing a functionality, alternative means of implementing a functionality. So this can be done by you doing some research or surveys. Based on that, a preliminary design is made, which can be further optimized by collecting user feedback. For example, the basic function of a car is to transport people. This can be achieved by using a petrol engine, a diesel engine, a gas engine, or an electric engine. So those are the means by which we can implement this function of the car, which is transporting the people from one place to the other place. Qualities of a design engineer. A good design engineer should have the following qualities: problem forming and problem solving skills, scientific temper and proficiency in STEM, science, technology, engineering, and mathematics, a creative approach for generating new ideas, an excellent know-how of engineering and design principles, a knowledge of the qualities of the materials used in the design, an in-depth understanding of manufacturing processes and construction methods. A good technical and communication skills, good morale, ethical and professional values, good team working skills, business and managerial acumen, culture exposure, sensitivity, understanding, etiquettes and manners, self-confidence and optimism, concern for environment, sustainability and safety, a sound knowledge of computer-assisted design software. Now let us look at the design process and various stages of design process. In contrast to other domains of design, engineers identify many alternate practical solutions to a problem and then evaluate these options and choose the best solution from these alternative solutions. So in order to do this activity in an effective and efficient manner, engineers often follow a systematic and iterative procedure known as the design process. Design process is divided into many different steps or phases, as few as 4 steps to as many as 9 steps, proposed by different researchers as well as different books. However, all these different frameworks will have some basic steps or stages in the design process which are listed below. Detailing customer requirements, setting design objectives, identifying constraints, establishing functions, establishing specifications, generating design alternatives, evaluating alternatives, and choosing a design. So these are the different stages in design process. Let us look at these stages in detail one by one. So these are the various tools and techniques for identifying the needs of the customer. Focus group meetings. So you can have a meeting or brainstorming with key people from all the different stakeholder groups like end users. You can have people from end users, manufacturing department, service and maintenance department, operational department, sales department. So convene a meeting or a brainstorming with all key people from different stakeholders. You will be able to get a lot of inputs on customer needs and requirements. You can also have telephone interviews with key people of different departments, end users as well as other stakeholders. You can also have a face-to-face one-on-one interview with people. You can get appointments for interview from different departments and go there, have a face-to-face one-on-one interview. You can also prepare a list of questionnaires and send to the customers and get it answered by the customers. Or market survey is another best way of collecting the needs or requirements of the customer. You can also search web, patents, journals and newspapers to understand the needs or expectations or requirements of the customers. Whenever you do an interview or prepare a questionnaire, the questions have to be formed in the right way in order to get the requirements or needs. So these are the guidelines for preparing, how to prepare the questions for interviews or questionnaire. Always start the interview with an open-ended questions so as to collect maximum information. When you ask an open-ended question, the customer is forced or encouraged to explain the requirements. If you start with a closed-ended question, the answer to the question will be either yes or no, true or false, single word answers. So your aim is to get maximum information about the requirements. So always start with open-ended questions. And this could be followed by doubts clearing and clarification question if something is not clear during this while customer explains the requirement. After he completes explanation of his requirements, you can follow up with clarification questions and doubts clearing questions. And towards the end of the interview, you can ask specific or closed-ended questions. That should be the approach to be followed during an interview. So you need to ensure that all questions are unbiased and always avoid leading questions or negative questions. Leading questions are questions that will lead to an answer expected by the questioner, by the interviewer. That is not required. So don't ask leading questions which will force the customer or the user to give an answer which is already expected by the interviewer. Also avoid negative questions. Include a question to get an idea on how much a customer would be willing to spend. You should also have some idea on the budget or the cost that can be borne by the customer for the product. So include questions which will help you to get an idea on what's the budget of the project, how much the customer is willing to. Introduce only one issue per question. Ask few conflicting questions and compare the answers to ensure consistency. It is one of the good technique in order to avoid, in order to get clear requirement of the customer. It is always better to have, it is sometimes better to have conflicting questions. Same question asked in two different ways and compare the answers and see whether they are consistent. If you ask the same question in a different way, the answer from the customer could be different. But you need to check for consistency of the answers and see whether their answers are contradicting with each other for the same question asked in two different ways. Ensure that the questionnaire is easy to read and complete. Test the questionnaire initially on a pilot sample among your friends and family members, a small group of people, before sending the questionnaire to a large sample of people. Market survey is another good technique to understand the needs or expectations of the customer. One popular technique is called like-dislike method. So it looks like this. You can prepare a survey form like this. This survey form includes 3 sections: likes, dislikes, and suggested improvement. Suppose you are trying to develop a new mobile phone in the market, new mobile phone which is going to compete with existing 3 popular phones in the market. The company is going to introduce a new brand mobile phone which has to compete with existing brands, popular phones in the market. So you'll prepare a survey form like this. You will choose the best phone currently in the market, identify the best phone currently in the market, and have separate columns for each of these phones. And there are 3 type of questions, 3 areas you need to get the input from the customers of these phones: likes, dislikes, and suggested improvement. You take a print of 500 copies of this form and give it to some business school students. They will go and do this survey. They will go to some malls like Lulu Mall or Obron Mall and stand in front of the mall. Whenever a customer comes to the mall, he or she will look for the phone he is having. Suppose then the student finds that the customer is having a Redmi Note 4 phone. They will approach this customer and ask, why do you like this phone, Redmi Note 4? What are the features you like most in this phone? What are the things you dislike about this phone? Do you have any suggestions for improving this phone? So when you ask this question, customer will talk about lot of features that he likes in the Redmi Note 4. Some features he doesn't like in the Redmi Note 4 because of some reasons, and he may also give some improvement suggestions. Then you look for another customer who is having a Lenovo K8 Note 4. You go to him and ask the similar questions. What are the features you like in this phone most? What are the features you don't like in this phone? Do you have any suggestions for improvement? When you complete this survey with about 500 customers, you will get a lot of information, lot of insights on what are the needs of the customer for a mobile phone. What are the needs with respect to a mobile phone for the customer? What are the things the customers are looking for in a mobile phone? That insight you will get once you complete this survey with around 500 customers. So the customer needs or requirements should be solution neutral. When you collect the requirements, you should not think about the solution. You should be solution neutral. I should not document the requirements or needs as a solution neutral requirement or need, which will look like this. Provide pure and safe water throughout the year. Capacity to provide water for 200 staff members. Affordable price. Low operational cost. Low maintenance cost. Minimum space to install. Prompt service and minimum downtime. So this is how the customer requirements or need should look like. It should be solution neutral. Another example, hold varied quantities of water, heat varied quantities of water, boil water fast, energy efficient, easy to move around, safe handling during pouring, pour hot water without spilling, aesthetically pleasing surface, automatic switching off from energy source or alert user when water is boiling. You may think that it is a water kettle, requirement for a water kettle, but we cannot now decide what is the solution for solving these requirements or meeting these requirements, because you are not sure on what is the quantity of water to be heated, right? If it is a water kettle, it could be 1 liter, 1.5 liter, that's all. But if this requirement is for a commercial organization, the quantity of the water to be heated could be large. So in that case, they may be looking for a boiler instead of a water kettle. So when you collect the requirements, you should not immediately decide what is the solution you are going to provide for meeting these requirements. That's why I avoided the name of the product while listing these requirements. Another, mobile phone. Suppose your company is planning to introduce a new mobile phone in the market and you did a market survey. From the market survey, you can understand what are the basic needs or requirement features the customers are looking for in a mobile phone. Slim and compact, lightweight, bigger screen, long hours of battery charge, high quality picture and video, high internal storage, built-in apps. So these are the requirements the customer may look for in a mobile phone. Good performance. There is another requirement, automatic and crusher. This is a product where we can crush and reuse the aluminum cans of soft drinks. Soft drinks like Pepsi comes in aluminum cans. So after use, you can put it in this machine. It will crash and then it will go for recycling. While collecting and detailing the customer requirements, following activities are also carried out. Define the need or a problem at hand clearly in your own words, which is called need or problem statement. You can write 2-3 sentences to define the problem at a high level. Define the need or the problem at a high level can be done by writing 2-3 sentences in our own words at a high level. That is one activity you need to know. Define the problem. Define the problem statement or the need statement. And then look for requirements which are conflicting in nature. When you talk to different stakeholders of this company, they may have conflicting requirements. Manufacturing department may give a requirement which may be contradicting with the end user requirement. So identify such conflicting requirements, discuss with the stakeholders and try to arrive at a consensus and decide what do they want. In case, and resolve the conflicts. Some cases it may happen that even though the requirements are contradicting or conflicting, they need to have both this. They need to have the product support both these options. Probably the options could be contradicting. What our customers need, what the end user need, and what manufacturing department need could be slightly contradicting. But in some cases, you need to design a solution which will satisfy both these requirements. Or you need to have a consensus developed between the stakeholders and arrive at a consensus and resolve the conflict. Another activity you need to do after collecting the requirements is prioritizing the customer requirements according to the importance of that features for the customer. Then expand and organize these customer needs and requirements into objective tree, which will be done as part of the next stage of setting objectives. So another example, you need to prioritize these requirements based on the relative importance. There are some tools used for this. One of the way to prioritize the customer requirements is to use customer feedback from the market survey itself to rank the requirements. When you do the market survey, customer will be saying what do they like and what do they dislike in a particular form. If you look at the features the customers like and count the number of customers who likes that particular feature, you would be able to decide the importance of the feature for the customer. Suppose 500 people have completed the survey. Out of that, 200 people were talking about slim and compact form. So you can convert the 200 into a percentage, 200 divided by 500, a percentage of customers who are looking for that particular feature. Similarly, other features, so you can count the number of customers who were talking about that feature. Depending on that number of people who were talking about a particular feature, you will be able to rank the feature in terms of importance for that feature for the customer. That is one way of prioritizing. Another way is use the designer's experience, and designer can rank the requirement based on the importance rating based on their own experience in a scale of 1 to 10, where 10 is the most significant, most important, and 1 is the least important. Or it could be from 1 to 5, 5 is the most important and 1 is the least important. Another way is voting by the customers for the requirements. Customers vote for the requirements based on their individual preference. Moscow method is another technique that can be used for prioritizing customer requirements. That's a formal technique that can be used for prioritizing customer requirements. Moscow method, the word Moscow is an abbreviation for various buckets or categories of customer requirements based on the importance. The customer requirements will be put into different categories based on the priority, based on the importance. So Moscow method prioritizes the requirements by classifying the requirements into four categories. M stands for must have, S stands for should have, C stands for could have, and W stands for won't have. So must have are the features which are a must for the product to be released in the market. In the Moscow method, the priority is based on the product release priority. Based on the product release priority, the requirements are classified into four categories. So in order to release the product, if a feature is a must, if the product is not usable without that feature, then it is a must-have feature. For example, battery charger for an electric car. If for an electric car, if there is no battery charger, once the battery gets depleted, customer cannot use the car. So the battery charger should be a feature even in the first release of the car. So it is a must-have feature. Without that feature, the car or the product is not usable by the customer. Should have are the requirements which are important and will have an impact on your product. But it may not be very important for the current release, as there is a workaround for the customer to use the product even without this feature. Because the product will be still usable even without this feature, even though this feature is important. For example, automatic could have requirement is desirable but less important. Could be included if time and money allows, otherwise it can be avoided. For example, GPS in an electric car. Won't have requirements that everyone agreed not to include in the product at this point of time. It could be considered at a later point in time. For the time being, everyone agreed not to have this feature at the moment. For example, obstacle detection in an electric car. Another model for prioritizing customer requirements is Kano model by Professor Noriaki Kano in 1980. Here, requirements are prioritized according to the needs and expectations of the customer into 5 categories. 5 categories are must be, requirements of features that are expected by the customers but may not be expressed. Those are coming under must be category. They must be included in your product, otherwise customer will be dissatisfied. Its absence produces dissatisfaction and its presence does not increase satisfaction. These are the features which are expected by the customer. They may not express this, but these are expected. So if the feature is not implemented, customer will be unhappy, customer will be dissatisfied. But the presence will not increase the satisfaction level because these are expected. For example, brake for a bicycle, which is always expected. So it has to be implemented, otherwise customer will be dissatisfied. One-dimensional category. These are the features that make users happy when they are there and happy when they are not implemented. These requirements are normally stated by the customer. For example, a gear with 12 speed. A customer may specify this requirement. I need a bicycle with a gear with 12 speed. Attractive category. These make users happy when they are there, but don't disappoint them even if they are not implemented. There are some features which looks attractive and customer will be happy when they find the feature. But even if that feature is not there, customer will not get disappointed. Built-in MP3 player with headphone jack on a bicycle. Indifferent. These are the features that have no impact on customer satisfaction levels. These are features customer will neither be satisfied or not dissatisfied, irrespective of whether the feature is there or not. Bell on a bicycle. Reverse. These are the features which, if implemented, will make the customer happy. If not, the customer will be happy. For example, crossbar on a lady's bicycle. So this is a graph which shows different categories of customer requirements and the satisfaction level based on whether the feature is implemented or not implemented. These are the must be requirements. If it is implemented, the satisfaction level is neutral because these are the features which are expected by the customer. If these features are not implemented, customer will get dissatisfied. The dissatisfaction will be very low. One dimensional, these are the features customers normally state. Then in that case, if it is implemented, customer will be happy. If it is not implemented, customer will be unhappy. Attractive features or attractive requirements, if they are implemented, customer satisfaction will be high. If they are not implemented, satisfaction level will be neutral. They may not get dissatisfied because these are not expected but attractive features. If they find that feature, they will be happy. Even if that feature is not there, customer will not be dissatisfied. Customer will still be happy or neutral. And indifferent are the features which will neither make the customer happy or unhappy, irrespective of whether it is implemented or not. Reverse attributes, if it is implemented, it will make the customer unhappy. If it is not implemented, customer satisfaction level will be high. So this is an example of prioritized list of customer requirement based on importance from top to bottom. Provide pure and safe water throughout the year. 5 higher number indicate high priority. Affordable price 5, low operational cost 4, low maintenance cost 4, prompt service and minimum downtime 3, sufficient capacity to provide water for all staff, minimum space to install. Another requirement, prioritized requirements, mobile phone, long hours of battery charge, high quality picture and video, slim and compact, lightweight, high internal storage, good performance, bigger screen, built-in apps. Setting design objectives, that's the step 2 of design process. After understanding the customer requirements, the next step is to set the design objectives. A popular method for setting objectives is called objective tree. So what are the steps for developing an objective tree? Prepare a list of design objectives based on prioritized customer requirements. Order the list into a set of high-level and low-level objectives. Then group the objectives and sub-objectives and represent their hierarchical relationship as a tree diagram. Example for the objective tree development for a water purifier. Step 1, list of design objectives. Prepare a list of design objectives based on the requirements. Cost effectiveness, safety, can detect and remove chemicals, fewer repairs, easy to repair, long lasting, affordable price, efficiency, low damage, take least possible space, safe for humans, safe for environment, low maintenance, cleans high volume of water per minute, low power consumption. Step 2, order the list into sets of higher priority and lower priority. Safety, safe for humans, safe for environment. Cost effectiveness, few repairs, easy to repair, affordable price, low power consumption, low maintenance, long lasting and low damage. Efficiency, can detect, remove chemicals, take least possible space, cleans high volume of water per minute. drawing a tree diagram. Water purifier. Next level is safety, cost effectiveness and efficiency. Under safety, there are two subcategories: safe for environment, safe for business. Cost effectiveness, there are three subcategories under that: affordable price, low power consumption and low maintenance. Long lasting, under affordable price, long lasting. Low maintenance, few repairs, low damage and easy to repair. Efficiency, take least possible space, can detect and remove chemicals, cleans high volume of water. Another example, objective tree for the automatic coffee. Third step of design process is identifying the constraints. Constraint is a limitation you impose on the degree of freedom of a solution. Constraints can be on economical constraints, technical constraint, political constraint, legal constraint, environmental, or refer to the resource of your project's plan, its target location, or to the product. For example, constraints for design of water purifier could be: should meet WHO drinking water standards, price of water purifier should be less than 5,000, power consumption of water purifier should be less than 60 watt, storage tank capacity should not be less than 5,000 ml. Constraints for design of automatic can crusher could be: can should be in good condition when supplied to the device. Maximum dimensions of the device are not to exceed 20 by 20 by 10 centimeter. We should crush a minimum of 100 cans per minute. Price of the automatic can crusher should not exceed the given budget of rupees 10,000. Establishing functions. As step 4, establishing functions. This step in design process involves converting the customer requirements into functions. Customer requirements are wish lists, and functions are solution neutral actions that the product will perform. We are still in the problem domain, so the functions will also be written as a solution neutral function, which will be performed by the product. Functions should consider what the product does, the problem, and not how, the solution. Overall function of a product is the relationship between its inputs and output, which can be further broken down into subfunctions. The overall function of a product can be considered as a conversion of the inputs into output, so which can be further decomposed into subfunctions. This process of decomposing the functions into subfunctions is known as functional decomposition and is represented as the functional structure. The steps of functional decomposition of a design and representing it as a functional structure are listed below. Express the overall function for the design in terms of conversion of inputs and output as a black box model. As a black box, it is called black box model. Now, identify the subfunctions within the black box and draw those subfunctions. Break down the overall function into a set of essential subfunctions, and this is called transparent box model. Now, draw a block diagram showing the interactions between the subfunctions, that is function tree. Then draw the system boundary and show the interrelationship between all the subfunctions and the function, which is called function structure. And in the next stage, we will look for appropriate components for performing each subfunction and its interactions. So that is the step of generating design. So this is an example of establishing function for water purifier, black box model for a water purifier. Input is contaminated feed water. The second input is energy, which is solution neutral at the point of time, because energy can be supplied in different means. So we have not decided what should be the energy. So it is solution neutral. Output clean water, and another output is impurities, rainwater containing impurities. transparent box model. So the function can be further decomposed into subfunctions. So inside the water purifier, there will be other subfunctions will be filter sediments, filter dissolved salts and chemicals, store clean disinfect bacteria and other microorganisms, store clean water, drain sediments, salts and chemicals. This is a functional tree for the water purifier example. Feed contaminated water, filter sediments, filter dissolved salts and chemicals, disinfect bacteria and other microorganisms. In all these three subfunctions, it will go to drain sediments, salts and chemicals. Now here, so store clean water and deliver clean water. This is the function tree. This is the functional structure diagram, including all the inputs and output and the relationship between all subfunctions and the main functions. Contaminated feed water goes to feed contaminated water, filter sediments, filter dissolved salts and chemicals, disinfect bacteria and other microorganisms. From filter sediments, filter dissolved salts and chemicals, disinfect bacteria goes to drain sediments, salts and chemicals, then store clean water and deliver clean water. This is an example of a functional structure. This is another example for automatic and pressure functional structure. Functional structure for shopping cart example. So these are the reference books used for preparing this presentation. Engineering Design Process, Yusuf Faiq and Tamer M. Shakeen. Also another Indian book, Design and Engineering by Jayasri Balan and Joy Varghese. Questions?